All right, so finally in this video, we're going to go through and do our 5 steps for the hypothesis test. So we're going to still be working with our President Trump example here and actually go through to see if there's a relationship between feelings about the president and whether or not we had voted for him. So we're going to test our relationship using a 1% significance level. So that's telling me then that my alpha is going to be 0.01. All right, so our first step is to write out our hypotheses. So my null hypothesis is that the response variable, which is feelings about the president, are independent of voting for Trump. Or again, that's the idea of no relationship. Our alternative hypothesis is the same idea, except for that it's dependent, or that there is a relationship. So feelings about the president are dependent on voting for Trump. Or that there is a relationship between our two variables. The one does impact the other. All right, step 2 is our decision rule. So we are going to reject the null hypothesis, which then actually means we're going to believe the alternative hypothesis if our p-value, or again can just refer to as probability, is less than our alpha, which we were told was 1%, so our 0.01. For step 3, we will go ahead and do the conditions here. So we still need the idea of a relatively random and unbiased sample. So we're going to go way, way back here to the very beginning where we talked about this example. All right, so we took a random sample of 50 adults from each of the 50 states. All right, that seemed to be biased. We're making sure we get some people from each state. We're not only sampling like Republicans in each state, so a random sample of 50 adults in each of the 50 states. Technically a stratified sample here since we're taking a sample from each of the states. There's really not any known bias for what's going on here. And then we need all of our expected counts to be at least 5. So I'm going to go ahead and list out all of my expected counts, which if I scroll here then to my next page, I have all of those numbers, both in my output and how we calculated in the video last time. So let me write all of those numbers down. All right, all those numbers, at least 5. Yes, my smallest one was the 68.34. So yes, they are all at least 5. The other part of step 3 is to get our test statistic. For now, we're just going to pull that number from StatCrunch, and here in a little bit, we're going to actually do the calculation. So our chi-squared value, so it's where this chi-squared is labeled, and it's the actual value. So this 350.32713 number is our actual value of our test statistic. So right now, I'm just getting that number from StatCrunch. Again, we will actually show you how this number is calculated here in a minute as well. All right, for step 4, we need to get our p-value or our probability. And that's also just going to come from StatCrunch here. That's where we will always get it. And the p-value is so small, it's smaller than 0.0001. Going back to our step 2, we're asking ourselves, is that p-value we just found less than 0.01? Well, yes it is. So we will reject the null hypothesis. We will then believe the alternative hypothesis. So then when I write out my step 5, I always start with my significance level. And then, is there or is there not statistically significant evidence? Well, since we rejected, it is statistically significant. To support. And my last thing is the alternative hypothesis, but in words. And here for us, it already is in words. So there is evidence to support that feelings about the president are dependent on voting for Trump. So we decided then there is a relationship. The one does seem to influence the other. Which, if you just read that final statement, it's kind of lacking a little bit. So saying, yay, there's a relationship, but it doesn't really tell us what kind of relationship. That is, well, how does voting for Trump impact your feelings about the president? Does it make them better or does it make it worse? Like, right, it doesn't say that anywhere in this interpretation. Now, we've already seen from the data how that's influenced things, but we don't really see anything here. So to figure out where that relationship really is where that calculation of that test statistic is helpful. So that's why I left us some room here, is we're going to calculate this test statistic. So how do we calculate the chi-squared? So let's do it. So if I look at my formula for it, it has a sum, which again just means we're going to add some numbers together, of the observed count minus the expected count squared over the expected count. I have those numbers in my output. So my first row here are my observed counts, and my last row are my expected counts. So for like this first one of the no approve, my observed count will be the 298. My expected count will be the 517.18. So when I write it out for that piece, it'll be 298 minus 517.18 squared over 517.18. Now where the sum part is useful, I've got to do the same thing for this next cell. But this time my observed count is 987, and my expected count is the 762.16. That same process. And I'm just going to do the same thing for each cell. So moving over here. Moving down here. Here. And finally, here. All right, so finally, after all 6 of those numbers, we're done. So we don't do it for any of the totals that we have. All right, then going through and actually doing the math. I just rounded these each to 2 decimals. So when I do this 298 piece here, I get 92.88. For this piece, I got 66.33. And for this piece, I got 0.39. For this piece, I got 110.99. For this piece, got 79.26. And for our final piece, I got 0.47. And then finally, after I do all of that math, I got 350.32, which is pretty darn close to what they got up here. So that's how that number is being calculated. Okay, still great. Now what do those numbers or those little pieces I just calculated actually mean? So keep in mind that the expected count is calculated assuming they are independent. So if I was expecting 517 people and I got 517 people, I'm probably going to think it's independent because I got exactly what I expected. If I had 517 minus 517, that's going to give me 0. 0 squared is still 0, so I'm going to get 0. So if they're independent, I would expect these numbers to be really close to 0. The larger those values are, the more evidence for me to think that there is a relationship or that they are dependent. So the larger the contributions to chi-squared, this is what leads to us rejecting the null hypothesis. When I'm talking about these contributions, I'm talking about these individual pieces. So if I look at those 6 numbers, which of those numbers are big? So if it's close to 0, it's not big. So I can't get negative numbers here, so we're only looking at how far it is from 0. Well, that number is pretty big. That number's pretty big. That one's pretty small. This one's pretty big. This one's pretty big. Where did those numbers come from? Okay, those came from the no approve, the no disapprove, the yes approve, and the yes disapprove. I am not too surprised by this. Why am I not too surprised? Well, let's go way back. When we looked at our data and we had the two pie charts, which pieces from one pie chart to the next look different? Well, the blue pieces look pretty different in size. The red pieces look pretty different in size. The green don't really look all that different. So that's what I'm seeing here as well. So where is there a difference? Where is having voted for Trump having an impact? Well, it's having an impact on our approving or disapproving, but it's not really having an impact on us feeling neutral. And probably not too surprising. Now here's some good news. So I would like to be able to look at these numbers to figure out kind of, again, where the relationship is happening. But I really don't want to have to do this math every single time. The good news, StatCrunch will do that piece for us as well. So if I go back to StatCrunch where we were last time, I had created this table of output. I'm going to go to the same place I just was for that. So that was under Stat, Tables, Contingency, and for this one I have the data. My row variable was voting for Trump. My column variable was opinion about the president. And last time I clicked the row percent and the expected count. There's this last one I didn't click last time that's called contributions to chi-squared. I'm going to click that one this time. And I have the same output I had before, except for now my very last one are those contributions to chi-squared, which would be very close to what I calculated myself. So they got 92.89. I got 92.88. We got 66.33. They got 66.33. So each of those last numbers are the pieces that make up this 350 number that I have down here at the bottom. So if I add all those 6 numbers, we should get something pretty close to our 350.327 number down here. So that's another way of looking at the chi-squared contribution, but hopefully having seen it calculated once, you have an idea of what it means. All right, hopefully after this example, it makes some sense. Make sure you feel comfortable with doing this in StatCrunch as well.